Canada loses a lot of homes to tornadoes. There's places in Canada that get a lot of tornadoes. We have known for over a century how to build houses to be resistant to tornadoes. We just haven't done it. There's a voluntary standard that sets out, called CSA S520, that sets out about a dozen features that we can build into our buildings that would enhance the building code to make houses resistant to tornadoes. Without these features, a house will start to fall apart when it's hit by the beginnings of an EF0 tornado. With these features, a house can resist EF3 or greater wind speeds. There's about a dozen features in the standard CSA S520 that contribute to the strength against tornadoes. I'm going to show 6 of them. Now, one thing you have to understand when thinking about tornadoes is that they make a house act like a wing. There's a phenomenon called the Venturi effect, where fast-moving air exerts lower pressure than still air. So the fast-moving air from a tornado that blows over your house exerts less pressure on the upper surface of the roof than the still air inside exerts on the lower surface. And what that means is that there's an upward force on the house trying to lift it up off of its foundation. Now, to keep the house all in one piece, you have to hold the topmost pieces onto the house and hold the upper parts of the house onto the lower parts of the house. It's called a load path. You have to make sure that every link in that chain holds. These are 6 of those features. So what I'm not showing here is a connection between the roofing shingles and the roof sheathing. So here's a roofing shingle, and normally we install these things with 4 nails per shingle, and the standard calls for 6 nails per shingle, making that connection 50% stronger. Another feature is are stronger nails. One can use these ring shank nails to connect the roof sheathing, that's the plywood or the oriented strand board here, to the roof rafters here, and that adds $88. Those nails are just marginally more expensive than ordinary nails. The standard also calls for thicker sheathing. This is 5/8 inch rather than 7/16 of an inch plywood. Trusses are then held onto the top plate of the upper story wall, either with a hurricane strap like this, or a truss screw that you can just barely see. This little red end here is a long 6-inch screw that's drilled up from the lower plate, the underside of the top plate into the truss. And those cost about $1.80, and there's might be 125 of them in the average house, adding $230 to the cost of a house. Then there's these hurricane straps that hold the top plate onto the studs. Moving around to this side, these strap ties connect the upper story walls to the lower story walls with nails all along here, just preventing the tornado from lifting up the whole second story wall and taking it away. This holds it down there, and these might add $150 to the construction cost of a house. There's also some more nailing down here to connect the walls at the bottom story to the bottom story, the wood right above the foundation, this rim joist and this sill plate. And those additional nails might add $50 to the cost of a house. Moving back to the foundation here, this gray piece of wood, this piece of wood that's painted gray here represents the concrete in the foundation, and you can barely see it, but there are anchor bolts that connect this sill plate to the foundation. The building code has them at every 8 feet, and this standard CSA S520 would place them a little bit closer together every 6 feet, and that adds a few anchor bolts, maybe 6 more anchor bolts for a 2,000 square foot house, adding about $60 to the cost of a house. You add up all of these features and all the other ones that improve the uplift capacity of the house, and all those things might add $3,700 to the cost of an average house. But on overall average, long-term average, they avoid a lot of future losses. Long-term average, they will avoid at least 3, possibly 20 times the added cost of construction in future losses. So benefit cost ratio of at least 3, potentially 20 or more on long-term average. And places that have higher, more frequent tornadoes or stronger winds, that benefit cost ratio is higher.
Find out more about our research at ICLR.org.